simplifying radicals, page 13 in your notes. One of the first things we are looking for is, first off, radical expressions. They can contain a radical, because we can have something like 4 square root 3. That is considered a radical. That's a simplified one. If it is not simplified, we need to simplify it. So underneath that radicand, you can have no perfect squares, which means you cannot have something like this, the square root of 50. Why can't we have 50? Because 50 can be factored as 25 times 2, which gives us 5 square root 2. This is in simplest form. Square root 50 is not. Under the radicand, you can have no fractions. So when you look down here, this one is not considered simplified, whereas here, please no comments, this one is considered simplified. Because when we are looking at that, the 4 is not underneath the radical symbol, okay? So here, these are not considered simplified. There can be no radicals in the denominator of a fraction. So again, can't have a fraction, can't have the denominator being underneath that radical. So as we are looking at those. So on the next page, or that next screen down in your notes, it says that we want to simplify the square root of 160. This is what we've been doing. We have been looking at this since we started on G2 when we were simplifying our radicals. We went to a perfect square, 16 times 10. Now some of you like to break down 16 as 4 times 4, and then say the square root of 4 times 4 is equal to 4, but the square root of 16 is 4, and you can go right to the step with 4 square root of 10. So is it completely simplified? Is there a perfect square that goes into 10? No. So is it completely simplified? Yes, completely simplified. So we want to look at square root of 72 and the cube root of 16. If we are taking a look at the square root of 72, again, for some of you, putting that list of your perfect squares, 1, 4, 9, 16, 25, 36, and you really probably don't need to go much more than that, maybe 49. What's a perfect square that goes into 72? 9. 9 times 8. Now if I do 9 and 8, did anyone pick a bigger one? Could you have picked a larger number than 9? We could have went with what? 36. And if you don't recognize 36, then you're going to go with 9 and you go, oh, this is going to be the square root of 9, which is 3. But I need to factor square root 8. How are you going to factor 8? Perfect square would be 4 times 2. I now have 3 times the square root of 4 is just 2, and I'm left with square root of 2. So my answer when I am looking at that one is going to be 6 square root of 2. Could someone else have solved the problem and showed me this one? Square root of 16 times 2, or not 16, 36, right? Divided 72 by 2 and got the same answer in a much shorter process. Yes. Cube root of 16. If we are simplifying, the cube root of 16, again, 1, the next cubed is 8, the next one is 27. Obviously it can't be 27, so 8 goes into 16 how many times? So we have 8 times 2. The cube root of 8 is 2. You're left with the cube root of 2 when you look at that problem. Okay? Simplify by removing a variable. Sometimes you simplify the radical expression that contains variable. Dealing with square roots. Any exponent that is divisible by 2 is a perfect square. Which means if I am taking the square root of x to the 8, I am simply going to divide 8 by 2, and it's going to leave me with x to the 4. But if I have the square root of x to the 9th, I can't just divide 9 by 2 and say the square root of 4 1/2. I then need to break it apart to an even, so x to the 8th. This is why our exponent rules, because I know that 8 plus 1, as you're writing this down, some of you aren't writing, but that might be a good idea, that 8 plus 1 gives me 9, and now if I'm looking at this, I take 8 and divide it by 2, which gives me x to the 4th. And I would be left with the square root of x. So x to the 9th looks like this. If it's an even power, it's simply going to equal half of that. Because that's what this is telling us to do. Remember in exponential form, this is x to the 8 divided by 4. Or x divided by 2. 8 divided by 2, my mistake, which is 4. So it says when dealing with cube roots, you got to have a power divisible by 3. So when we are looking at this one, they simplified the square root of 54 n to the 7th. First thing, look at your perfect square. It's going to 54. I would not necessarily suggest that you write like the 9 and then go n to the 6th. Could you write this? Would this be the same if you would have started and put the square root of 9 times 6 n to the 6th? And same thing as here. So whichever way you prefer, if you like putting your perfect squares kind of together, so the square root of 9 is 3, n to the 6th, we're going to divide it by 2. And we can't simplify square root 6 or n, so we leave it. So it says, how do we get 3n to the 3rd? And our answer, square root of 9 is 3. N to the 6th, we can think of that as 6 divided by 2, which is n to the 3rd. So we're still using those exponent properties from the last unit. Okay? So we are going to be simplifying these next two. I want you to try it, get started on your own, and then we will go. We were looking at Alg, you said you went 243 and you divided it by what?
Well, first I did 9, but then I did
81 times 3. I'm going to break down that x to the 5th. Hayden, how am I going to break it down? X to the 4th times x. I don't have to put an x to the 1 there. Okay? So if you would have gone 9, you just have a lot more steps to do. I like to prefer to go less steps if I can. So square root of 9, if I'm looking at it, Lulu is. Or square root of 81, excuse me. 9. Square root of x to the 4th, Christian. X to the 2nd. I can't find the square root of 3, that's going to stay underneath there. And I can't find the square root of x, so square root of 3x is the simplified answer. Okay. As I'm looking over at this one, I have a negative 1m, and it's going to be times. As I start to do the 80, Caleb, what do you think of the perfect square that goes into 80? 40 times 2. 40 times 2. Now, neither one of those are perfect squares. So I think of 2. So instead of 2, I might go with 4. 4 times what? 20. 4 times 20. Brooklyn, I'm breaking down the m to the 9th as m to the what? 8 and 1. Okay? So I have this negative 1m. Am I going to have to factor 20 further? Is there a perfect square? Okay, so the square root of 4 is 2. The square root of m to the 8th is m to the 4th. I have left square root of 20m. One of our perfect squares divide into 20. Yes. So I'm going to multiply these, multiply my variables together first. Negative, or my coefficients, negative 1 times 2 leaves me with a negative 2. M to the 1st and m to the 4th, using my exponent rules, is m to the 5th. Square root of 20. What perfect square am I looking at, Tristan? 4 times 5 and m. So I have negative 2 times. I might put my square root of 4, which is 2. I have m to the 5th, and I'm left with square root 5m. So when I am looking at my answer to the problem, it should have been negative 4m to the 5th, square root of 5m. Some of you, when you start looking at this and you go, okay, 2, 4, you might have gone right away, and if you would have gone with 16 times 5 times m to the 8th and m to the 1st, much quicker problem to get there, right? Much, not as long as a process. So those of you that pick the smaller cube roots, square roots, you just have a lot more that you have to do. And you really got to watch out, because some of you will stop at this point. And you'll go, oh, that's simplified, it's 20. Go back and think through that list of your perfect squares and see if it makes sense, okay? All right. So then we have someone we're going to be multiplying. You got this really ugly thing that you're multiplying. Out in front you have the 2 square root of 7t times 3 square root of 14t squared. So multiplying whole numbers, use the multiplication property in your square root. So we're going to take the 2 times the 3, that gives us a 6. So you're just multiplying those together. Then underneath my square root, I am going to take the 7 times 14. Now, I can multiply 7 times 14 and get that 98, but I also could do this, and I want you to think about this. If I would have had the 6, and I leave it as square root of 7t times, how would we factor 14? 7 times 2, and I have t squared. Okay? So if I did this in that first day when we did the video, because if I multiply it together and it's this huge number, I might not recognize any perfect squares that go into it. But if I look at this and I go, oh, I have 2 7s. 2 7s can be pulled out, and I have 6 times 7, which we got way down here, right? Because if I have 2 7s underneath, I can pull that out, and it's not any, because that's the square root of 49. And I have this t squared, which the square root of t squared is just going to be t. And then I am left with what's underneath, which is still, if I am looking at that one, 7 and t, or t and 2, right? 2t. So this is one way you can multiply it and then break it down, but you don't have to multiply those together. And especially like when I look at this problem down here. I am going to take, I'm looking at cube roots, okay? So I know I have 3, and this is a 1 out in front if there's really nothing there. So I have 3 times. I'm looking at the cube root of 32 times 20. Now, I might multiply those together, but I might be trying to think of what are perfect cubes that go into 32. And if I can't recognize a perfect cube, I might divide it by what? 2. But is there a perfect cube? Does 8 go into 32?
Yeah.
8 times
4.
8 times 4. And if I think of 20, 20 is 4 times 5. 5's a prime, right? So I am looking at this. What do I know the cube root of 8 is? 2. I got 2 4s. How many 2's is that? This is 2 2's, right? The first one, 4 is 2 times 2. This 4 is another 2 times 2, and then we have 5. How many do I need for a cube? I need 3 of them. So I have this 6, right? This was 6 out in front, times another 2. The cube root, this is 16. If I look at those prime factors, I have 2. And then I'm left with the cube root of 5. So when they were looking at that answer, the answer should have been 12 times the cube root. Oh, what did I forget here?
The other two.
The other 2. I did. And this should be 10, not 5. Okay? Because we pulled these 3 2's out, and we were left with these 2. What did you do for 8?
Yeah.
Oh, so the cube root of 8 came out right away as 2. This is the cube root of 8. Okay? Not underneath the square cube root symbol anymore. Okay? 3, and if I'm looking at 7 times 3, I should have Aiden. 6. So I got 21. I'm going to have my 5 times 20. Now, 5 times 20 is, does it make sense to multiply that together? Yes, because 100 is a what? Perfect square. Now I have x to the first and x to the fifth. That's going to give me x to the sixth. So I have 21. So sometimes does it make sense to multiply them together? If it's a perfect square, I recognize definitely. And the square root of 10 or 100 is 10. I'm not going to put square root anymore. I have 21 times 10, and the square root of x to the sixth is x to the third. 210 x to the third. So it kind of depends on the problem and the numbers. If I'm going with the cube root, I kind of want to think of 8, 1, 8, 27 or 8, 27, 64, breaking it down. And some people would recognize that this one would have been larger, but a lot of you don't recognize those large numbers. So on that next page down, I'm going to give you a minute. Do the top 2 first, and then we're going to kind of check. Lizzie, how'd you factor 525? 25 times 21. I'm going to go c to the 6th and c. So if I'm looking at my answer, Jack, I should have had
5c to the third square.
yes. Okay. 24 times 32. Before I start doing that problem, I am just going to take 24 times 32 because I just got to see, like, what is that number? Is it anything I recognize? 768 does not help me. I don't want to multiply these together because it gets so huge. Like when we multiplied the other ones and we got 100, that was nice. But this one, we don't want to. So we're thinking right away of putting your numbers together. So the square root of 24, what perfect square goes into it? So I'm going to go 4 times 6. How about 32, perfect square? Go large. Go bigger.
16.
16, right? 16 times 2. And then I'm left with the A and the B, okay? So, all of these are being multiplied. The square root of 4 is 2. The square root of 16 is 4. I have 6 times 2, A and B. 6 times 2, I'm going to multiply that. That is 12AB. Am I done?
No.
No, because the perfect square that goes into 12 is 4. So this is 8, right? And I have 4 times 3AB. So if I'm looking at this one, what am I looking at? Why?
No idea.
No idea.
Got 'em.
Okay, that's all right. 8 times the square root of 4, why it is? I'm looking at the square root of 4, it equals
16.
No,
No,
just the square
2.
root of 4.
2.
Yes, I agree. When we multiply those two, it is going to be, I agree, it is going to be 16. Quiet back
got
there.
you.
Quiet. So, left with what else?
Hush,
Quiet. What else do I have?
One.
Can you pull out the 2 left with? 3 and AB. So I am going to multiply those, I agree. 16, 3AB. Benson, we're looking at that next one. Gonna start us off. The 2 numbers are out in front are 4 and negative 8, so I want to multiply those first. And I get negative
32.
negative 32. I might on my calculator take 15 times 5, but really those aren't too bad. And if I go 15 times 5, what do I know if I was going to factor 15? 5 and 3. So could I just write down 5 times 3? And then I have h here and an h here, which is going to give me h to the second. And I have k to the second and a k. Do I want to multiply those together?
No.
No, keep it as k to the second and k, because we're always looking for even powers. And I still have this 5 back here, right? So I still have times 5. Now, if you like organizing and putting all your numbers in one spot, like all in the front, then just leave some room. But remember from that video, we said if I have 2 of them the same and I have a 5 and a 5, I can pull that out, right? So this is going to be negative 32, because that would have been the square root of 25, which is simply 5. I am now going to have h to what power as I'm looking at that, Emily? Okay, so I have h to the second here, so when I'm finding the square root of that, it is just going to be h. K to the second, Evan is going to be just k. And I am left with what underneath my radical? What's that? 5k. Didn't we pull both the 5s out? Just k. Was there any other numbers underneath there that I didn't pull out? The 3. So we want to keep that there. So we're going to multiply. Negative 32 times 5. What would you end up with? Negative 32 times 5. By all means, use your calculator. Negative 160. H, K, square root 3K. Okay? So I know some of them look really ugly as you are doing them, But if you when you multiply them and they make sense to give you a nice easy number, like when we were doing this one over here, and 5 times 20 is 100 and it's a perfect square. But if it's not, my hint would be don't multiply them and try and look at the factors of those. And remember that once you have two of the same things underneath there being multiplied, even if it's 25 times 25, you can pull that up. Your assignment, and I want you to notice that the is from the textbook.